Welcome to Spring LIB.
I think I got all the details here. We have the farmer's barn, and on the north wall, he's going to build a pasture or a field or whatever. Oops. Okay, and he doesn't have to put fence on the where the barn is. Okay, and then on one fence, his neighbor is going to pay for part of that. I guess I should put that at the end of his barn. Maybe his barn is right on the edge of the property or something. Okay, so that's the blue one. His neighbor's going to pay for half of that. And then the green one, he has to pay all of it. And so the most he will spend is $5,000. And the fence costs $20 per foot. And so we want to maximize the area of the pasture field, or I forgot what it was. So we'll just call it area. So we want to maximize area equals, well, what's the equation for the area of a rectangle? Well, it's length times width, but we need to give our specific names. Let's call this one X because it's horizontal, and then these two will be length Y, so that's the lengths. So we're going to maximize X times Y, subject to, okay, the total cost has to be less than $5,000. So if it costs $20 per foot and he's paying for all of it and he has to pay for Y feet, that's 20Y, plus he has to pay for X of it, 20X, plus he only has to pay for half of this. So instead of being $20 per square foot, it will be $10 per square foot. And that's Y. Okay, I can't stand that Y, I gotta fix it. Okay, 20Y. So the first one is the cost for this part right here. Second one, 20X, cost for this. Third one, his cost for this. His neighbors have to pay the rest. And we need that to be less than or equal to 5,000. So let's just say equal to. All right, so if I simplify that a little bit, it's 30Y plus 20X equals 5,000. All right, anytime to find a maximum, you're going to take the derivative of the thing and then set it equal to 0. But the thing has too many variables. That's what the constraint is for. This is the constraint, sort of restrains the size of things depending on how much they cost. Okay, so we need to take out either X or Y. So you can decide, do you want to solve this for X or Y? I don't think it's going to matter. Let's just solve it for Y. 30Y is 5,000 minus 20X. Now, yeah, if I would have got 2,000, if I would have solved for X, I wouldn't have fractions on both of these. Okay, the zeros cancel, and we get 500 thirds minus 2/3 X. So area is X times Y, which is 500 thirds minus 2/3 X, which is 500 thirds X minus 2/3 X squared. All right, now we're going to take the derivative with respect to X, so we'll call it A prime. Derivative of a constant times X is the constant, minus the constant times the derivative of X squared, which is 2X. We're going to set that equal to 0. We're going to multiply this whole equation by 3, so there are no fractions. 500 minus 4X equals 0. So 4X equals 500. X equals 500 over 4, which is 125. And then remember, it wants to know the dimension, so it wants to know Y also. And it was 500 thirds minus 2/3 X, is that right? Minus 2/3 X. So that's 500 thirds minus 2/3 times 125. So that's 500 minus 250 thirds. So 250 thirds. or 83 and a third. So he should make it north wall, north fence, sorry, forgot what was I talking about. North fence, 125 feet. And then the west and east fence, 83 and a third feet each.